Well, good morning, and thanks for hanging in there for the final session here at the ESIP summer meeting. This is Karen Moe, and we are recording our session. Several people told me that they would have loved to come, but they have planes to catch. So what we wanted to do today is take a look at how we can improve the discovery and access to earth science data, in particular for the disaster response community. And so our cluster has been working in this area for a long time, maybe 4 or 5 years. But there's just so much to do, and our strong focus has been on trusted data. What I wanted to do is, okay, good. Yeah, so our agenda today is we're going to hear from 4 invited speakers dealing with a variety of topics that the cluster has been focused on, and a couple of examples of what the use cases that kind of drive our exploration for additional data. So I wanted to encourage people to go to this tiny URL, ESIP on Trusted Data session, and I have a feeling you have to do the caps on this tiny URL. But I've set up a Google Docs page there. And what I'd like to ask you to do is be thinking about what are the data needs and issues. And when you hear our speakers, make some notes there for work that the cluster can continue looking for and examining. And our goal is really to improve finding new earth science data products for an end user community, which may or may not have many GIS experts in it, but have a lot of people who know exactly what their job is, what kind of information they need to make decisions, and often need to make those decisions very quickly. So our goal is to improve the discovery to solve those kinds of problems and improve access. Our second part of our session will be a discussion with a panel that we held earlier with with representatives from NASA, USGS, NOAA, and FEMA. Actually, our USGS participant was not able to make it at that particular one, but we've recorded that session, and we're anticipating that Marie will be joining us today, and that we can have some discussion about their ideas on how to do some cross-platform data access for this trusted data. So with that, what I would like to do is have our first speaker, and let's see, I'm going to try to bring these up. And let's see, what's the best way to get the slides going so I can introduce Chris Macintosh, who's been working with the All Hazards Consortium to look at what we're calling operational readiness levels. And the purpose is, as the title of his presentation, really increasing decision maker confidence in data. So Chris, let me turn it over to you.
Thanks, Karen. Can everybody hear me?
Very well, yes.
Okay, fantastic. Thank you, and thank you for the opportunity to talk to you about some of the work we're doing in helping the ultimate customer of data and information have more confidence and understanding of the information that they're looking at. A little bit real quick about my background. I was the Chief of Operations for Virginia's Emergency Operations Center, and then moved on and worked at Esri, where I was the Director of Public Safety Industries there. So I've been involved in this from both sides of the table, both as a decision maker and then as a platform and content provider. And those experiences have really informed the approach. You go to the next slide, please. And forgive my voice, it's East Coast allergy season. So when you think about who actually has to use data inside an operations center, it is not a technologist. It's an emergency manager or a director who does not necessarily have the background and understanding of all the nuances of data sets and web services and inline analytics. But what they do know is that they're faced with an immense amount of data, and they need to turn that data into actionable information that they can use to make faster decisions and also inform their stakeholders, whether it's government or the public, as to what's going on in an emerging incident or scenario. At the same time, they're also dealing with technology moving at such a rapid pace. There's so many disruptive innovations occurring in technology almost on a daily basis that they have to manage both. They have to create a program that turns all of this data that's becoming available very quickly, and manage what kind of technologies they're using to turn that data into information. And that can be things like GIS. It can also be things like drones, satellites, public safety broadband, so many of these things, and they're all coming together to kind of create a perfect storm of confusion, which is really paralyzing many agencies' abilities to move forward. Next slide. So, plus disasters are becoming more complex, and in this environment, they need to be able to answer questions and answer them quickly. And they also need to be able to trust the data that they're using to answer those questions. So when data becomes available, often at the last minute, or somebody comes in the middle of a disaster and says, look at the data I found. One of my colleagues, Carrie Hicks, uses an example of Gas Buddy data that became available, and they threw it into their decision-making tool and didn't really understand what it is that they were actually looking at, and caused some confusion. So these decision makers really need a way to know, what am I looking at, how reliable is it, and does it answer my questions? Next slide. So what we've done is we've got this work group through the size, and Dave Jones, who's also on this call, is working very closely with us on this. And the size consists of stakeholders across numerous industries, because the industries are in some ways a big part of the response to a major level incident. They actually have the resources that the community needs to recover. They have the transportation infrastructure, the utility infrastructure. So they have a lot of the data that we need in order to facilitate an effective response to a large-scale incident. We also, though, crosswalk that with the emergency management groups, who are leading this and coordinating these response efforts, because it's the fusion of the two that gives you the right information sharing environment to create actionable information. The ESIP Federation and others are a big part of this too. Trade groups who have conglomerates of industry, such as electrical or food management institutes. Federal agencies obviously play a big role, and others. We bring all those together, and we work through a process where we're starting to be able to identify some applicable data piece by piece, because we're also socializing this concept at the same time, and start identifying data that's relevant and provide a nomenclature, a taxonomy, where the ultimate consumer can decide what they want to use that data for. Next slide. Oh, I hear a dong. That's not good. There we go. So this group, our objectives are create planning, cross-section planning on what data is available and how that's going to be used, create simple processes for decision makers and GIS people to use that data to create the decision products and ultimately use that to reduce risk in using data and using information to mitigate risk to communities and facilitate effective responses. Next slide. So what's really important in this is this doesn't start with the data. This starts with the decision maker, the end user. So, and what the end user uses data for is to answer questions. So in the All Hazards Consortium, we craft use cases and start peeling them away in terms of what are the questions you need answered. When this scenario happens and you get called at 2 o'clock in the morning, most of these executives have a list of questions in their head that they ask right away. They may not be written down anywhere, but they know what they are. So we have to get those out, because once we know the questions, we can start figuring out how to answer those questions. We also need to know who's in their information sharing network and who are they working with, so we can start pointing to information sharing partners. Next slide. Now, once you do that, it's important to also have an understanding of how information sharing works. This slide shows the process from left to right. You have data sources, multiple different places. Those data sources can be used to feed a web map, which is an interoperable GIS construct. That web map can feed multiple applications, which are designed to fit user needs. Now, if you think of the previous slide, I started with what are the questions you need answered. We actually work this from right to left. What are the user needs? Understand the questions and understand how the user visualizes information, so you can craft the correct application powered by the right web map, including the look and feel and the content, the analytics and all of that, which is the web maps consuming data from the right sources. And when we get to sources, we get to the ORLs. Next slide. So this is another way of looking at that. We have use cases that we break down by sector. We break down by our ORL, which we then use to target specific data sets that match up to the right ORL levels. And I'll talk about the ORL levels here in a moment. So it's a process of mapping the question to the data is a big part of what we do, use case by use case by use case. Next slide. And there are those ORLs. Let me go to the next slide. And the ORLs drive the data sets. And I should have put the ORL slide first, but we're going to do it backwards. Next slide. And here are the ORLs. This is the important part. So how does that decision maker who says, I need to know damage assessment information, for example, know whether what they're looking at is authoritative, somewhat authoritative, not authoritative at all, or crowdsourced? What's the common taxonomy that person uses? And that's where the ORLs come in. So you can actually put this in your metadata of a data set. You can also have a conversation with that decision maker along the lines of, well, we don't have absolute ORL1 quality data. Government's very authoritative source. We know it's available, but we do have ORL2, which is a little less available. It could be sporadic, or even ORL4, which is crowdsourced. Is that good enough to answer the questions? And what you often hear is, well, as long as I know it's crowdsourced and I can take that with a grain of salt in my mental analysis of what I'm looking at, that's okay. So what we're doing is we're making sure that the decision maker knows exactly what they're looking at. What we often have done in the past is say, well, it's not authoritative, or we throw it out. Or we in the past, we say we don't have any idea of what we're looking at. This happened in in Haiti after the earthquake, there was data that made it into the decision tree that was coming from really unreliable sources, yet somehow it got into the situational awareness systems for search and rescue and resulted in search and rescue teams, which were desperately needed resource, being tasked with spurious missions instead of staying focused on vetted missions, and it caused a lot of problems and maybe it contributed to some people not being rescued in time. So this ORL standard is designed, you even put this in your dashboards so that people know this is ORL level 1 data in this dashboard. This is data you can take to the bank, or this is ORL level 3 data or 4 data, which is use at your own risk, but could be used to provide context to other data. So this framework is super important in turning data into actionable information. There is value, even in ORL level 4 data. There's a lot of value that can be had in that data, but you have to know what you're looking at. Next slide. So what's also very important is it's not enough to just focus on the data and put it in the metadata, because guess what? The emergency management director does not look at the metadata. So that this also has to be documented in the standing operating procedures of the EOC and of the roles and responsibilities of each job, so that they know exactly what they're looking at. So if I have this dashboard, let's use the damage assessment dashboard up, I know what in that dashboard is ORL level 1, that's authoritative, and what's ORL level 4, which could be social media detections. So you have to do both. Next slide. This is how it all comes together. You have the concept of operations in an operations center. Then you have the standard operating procedures, which lay all that out, including the use of the ORLs. The technologies are built to support that, even down to job aids and checklists, so that your just-in-time volunteers that come into the EOC and staff up many of the emergency support functions know what they're looking at. And then you have to train and exercise to it. So the way that this whole thing works is human. You have to address the human side and the technology side and bring them together. And that's why it's hard, and that's why a lot of data and a lot of these extremely powerful information products are not being used to anywhere near their potential today. Next slide. So that's really a real quick high-level overview of what the ORLs are and how they fit into what we're all trying to do with emergency management and public safety. I don't know, Karen, do you want to have questions, or do you want to wait till the end? Up to you.
Yes, thanks so much. That was excellent. If there were questions that to help understanding the content of the presentation, certainly would welcome that now. We have a pretty tight schedule, so I'm hoping to have time at the end for kind of more general questions when you see the whole scope of the other presentations as well. Any questions? Okay, so
Right.
Chris, yeah, thank you, and I hope that you're able to listen in on the other presentations.
Yes, I'll be here. Thank you, everybody.
Thanks. So our next speaker is Katherine Roden from NOAA, and she's going to be telling us about some specialized needs. And so how do we discover the type of data that might fit some of these needs? Katherine?
Hi, everyone. So yeah, I'm Katherine Rowden, and I am from the National Weather Service, but I'm not a meteorologist. I just like to say that right up front, because that's often a common misconception. So don't ask me difficult questions about that. So I'm here to talk about the post-fire hydrology issues. I'm a hydrologist. I deal with flooding, and in the post-wildfire environment, we have a lot of issues with flash floods and debris flows, like the Montecito 2018 event in California that killed nearly 24 people. So the way we find out what's at risk in those environments is typically done by a burned area emergency response team, a BEAR team. And they go out, they see how severe the fire was, how it affected the landscape, what's at risk downstream if it did flood or, major erosion events. They do a lot of science, they're crunching numbers, running models, and then they recommend mitigation actions that can be taken to protect people, structures, infrastructure downstream. Some cases, nothing can protect it in some bad cases. And they share those findings with the emergency managers, with the utilities, the community, whoever needs to know. One of the key things that kind of stops us in our tracks is they typically can't go out and do that until a fire is 80% contained. Well, in the old days, that might be fine when your fire's 10,000 acres, which even then was a big fire. These days, when they're 100,000, 250,000 acres, now they're like trying to tackle pieces of the fire while it's still raging over here. So that's a challenge. And only the federal and tribal lands have an official assessment team process that's funded, that has money to put in mitigation action. So if you're on state or private land, there is no formal process for that. Although some states are trying to tackle that. California is the most advanced. They actually have a funded team to do the state and private land. So that plays into what I'll be talking about here. So how do they do these assessments? So the first thing they start with is a BARC map, burned area reflectance classification. That's a fire perimeter in central Washington. So you take your pre-fire vegetation, your post-fire vegetation, you get the difference, and they come up with this BARC map, and that's what's handed to the assessment teams, and it's nicely color coded for fire severity, actually intensity, sorry, fire intensity, low, moderate, high. That's the language we speak when we're thinking about how it affected the landscape. So and those are created by the Forest Service or USDA and Department of Interior for their teams. And let's see, that mostly uses the Landsat and Sentinel satellites, and Sentinel is a more recent addition. So the teams take those remote sensing products, they start field validating it, looking, did the satellite truly capture the effects of the fire? There's a lot of false signals that can, get in there, as I'm sure you all know. Low, high severity, but they're also, their main focus is on the soil. Did it affect the soil in such a way that the roots are just completely dead? Is there a seed bank left? Basically, is this area going to grow back next year, or is it going to take 5 or even more years to grow back? And did it change the chemical composition of the soil? That's a big deal with, I guess that's on my next slide, hydrophobicity. It just means water repellent. So a soil that you might drop water on and it just absorbs, if you have an intense enough fire, it changes the chemistry of the soil in such a way that the water just beads up and sits there. It's really an amazing thing to see. You've got a pile of sand and a pile of water just sitting on top of it. So you can imagine the difference in a rain event before a fire and after a fire, how that water comes off. So that's one of the reasons we have these massive runoff events and debris flows. So you have that initial estimate from the satellites, the team goes out, field checks it, and comes up with a final soil burn severity product. So now we've translated the estimate of fire intensity down to the soil level. How bad is it? What's going to happen? That's just a picture of what came out of that fire in the first rain event on the fire. Nearly washed that semi-truck into the Columbia River. Nearly killed a couple people too. So they take that data and then they go and for about 7 days sit there for 12 hours a day, number crunching, report writing, designing fixes. This is just like the firefighters get deployed for 2 weeks. These team members, same thing. They're there till their job is done and then they leave. And a lot of specialties, looking at different things. But the problem we're running into with these bigger fires, and not even necessarily the bigger fires, but is we can get these floods, debris flows before their assessment's done. So you have a local community, an emergency manager, me at the Weather Service trying to figure out what's at risk, and we have no report that tells us what's at risk. So this is a picture 2014 in Washington, the Carlton complex. It was over 250,000 acres, the biggest at that time in state history. That's fire camp flooded. They are there fighting the fire and their fire camp flooded in this thunderstorm. That's one home. There were multiple homes affected, destroyed, highways washed out. That that was before we had a bear report. There was a small portion of the fire that was being assessed when this storm hit. So that was what happened in 2014. That got the attention of a lot of people, state emergency management now, because locally we'd been talking about this problem for a while, but people that aren't living and breathing it are kind of like, yeah, whatever. Well, this happened. It was already a federal disaster because of the fire. This storm hit, and finally, state EOC, FEMA is like, oh, okay, now we know what you've been talking about. And then in 2015 in Washington, we eclipsed our previous year's record with our largest fire season. Over 1 million acres burned in Washington that year. And so we just came out of this experience where we had this thunderstorm put out a mega fire and destroy everything in its path. And now we have 1 million acres on fire, and we don't know what could flood or where the debris flow could be. So it was a really interesting situation. So, state EOC picture, that's actually California. This is a picture of Weather Service operations and a forecast office. So you got 1 million acres burned. A thunderstorm could hit any of it any day, and we have no idea what's at risk. So that was an uncomfortable situation. And this is the fire detection, and that's kind of what the skies looked like for a lot of that fire period. Oops. So every time we would get a Landsat pass, it was typically too smoky to get any type of even early, satellite imagery. And at that time, they were mostly using Landsat 7 and 8. So it passes one time, and then you got to wait days and days for another pass. So we were actually out there, we on the state and private lands, the Forest Service, Department of Interior, the tribes. We were using helicopters, boats, cars, just driving around with paper maps, looking at the hills, literally hand mapping with markers and crayons, because we had nothing. You can imagine that was not super efficient. So that was kind of like, we need to do something better here. So I ran into some NESDIS people when I was at a NOAA meeting in DC who said, hey, we want to help through our fire and smoke initiative for post-fire. So we did a little pilot project on the Carlton complex from 2014, which had flooded. And that was the final map the bear teams did. And they said if we had used a satellite that could have gotten a picture when Landsat was passing and couldn't, or in between, but was coarser resolution, would that have been helpful? And I looked at the final map, field verified by the team, and a coarser resolution satellite image where we could have gotten a clear image. And yeah, as a hydrologist who understands this stuff, that would have been really helpful. So then we looked at 2015. Again, we had 1 million acres, no data. Is there something we could have gotten in the interim that could have helped? Because we were working in the EOC trying to map, just making it up, really. So that was using VIIRS, I think. And it probably doesn't show up to you guys, but I see these dark blue patches, and that's the final maps. They line up well with the dark red. So it's something that would really have to be vetted and tested, and how well do these images do. But for me, I look at that and say that would have been so incredibly useful to have in the state EOC before the BARC maps came out, before we had clear Landsat passes, etc. So kind of rolling with that, Thomas Fire in 2017 in December, those fatal debris flows happened the next month. So again, this whole fire to flood thing it can happen so fast. They were so lucky in this scenario that they did have BARC maps. They had a little preliminary assessment work done. The debris flow probability modeling had been done, and that was used for public outreach. So 23 people died in that. If we had been in that scenario where we didn't have that early remote sensing, or anything like that, we didn't have the debris flow modeling, so we didn't have that data, who knows how many people might have died. I mean, that was really critical information to help with the public outreach, to get thousands of people out of the way before this storm hit. So, I mean, 23 people died, but I see that as that could have been so much worse if we had not had remote sensing within that, again, December to January. It was really a few weeks time period. There's some pictures of that event. So the NESDIS project rolled into a JPSS Pilot, which is really just a web dashboard interface for Weather Forecast Office to say, what satellite images are available. Can we get something useful? So that's kind of in process, but things are happening so fast. In the last couple months, I've been working with the U.S. Forest Service folks that do their remote sensing. they came up with a Google Earth Engine tool last year. It's like, well, that's kind of it's a user-defined type tool, like, you know, we're working with JPSS to create. So we're experimenting with that. And just recently, we've been working with some folks at NASA. I don't know if it's anybody here, to get real-time NBRs into our operational forecast system. That's what, oh, I guess I didn't put that acronym up there. But somebody mentioned like the data type. So that goes into our operational forecasting system for the meteorologists. But I'm a hydrologist. I don't use that. When I'm sitting at a state EOC, I need that data in a KML or in GIS or, and right now that's not how it's being delivered. So, you know, and when meteorologists are the ones that are always talking to NASA, they're not talking to NASA about what I need. They're talking about, you know, as a forecaster sitting there. So trying to bridge that communication gap from an end user perspective has been challenging. I'll just say that. And then we're also, yeah, because the Forest Service and I think DOI are using more Sentinel images, we are getting more early images than we were, you know, a few years ago. And then I was talking with somebody at NASA, I think in the disasters group, Brady, I believe. We just had a really quick discussion because this project here is with NASA Sport. So we were talking about, you know, what's NASA Disasters doing? What did you guys do in California? You know, and mention this aerial, the aircraft stuff. You know, is there a way we could get that real time if you're capturing that imagery and turn it into this, you know, fire intensity estimate that we can use for, et cetera, et cetera. So all these ideas floating around. Now how to take that to, you know, have the discussion with the people that can actually test it, pilot it, you know, with us, the end users. So what else we need? Burn scar recovery year to year. So a fire is this bad this year, this is what the effects could be, but things start to grow back. So how do we change our warning criteria in the following years? And there's just too many acres for people to visit every year and update those maps. So we really have to rely on remote sensing if we're going to tackle this in any scientific way. And there is a project, the Monitoring Trends in Burn Severity, that does get updated imagery every year from, I think, most fires. But greenness, which is what the satellites are seeing, does not necessarily equate to how those soils are recovering. You know, you get a bunch of grass grow back, but that does not necessarily mean the soil structure is stable now with some grass roots. So how do we go forward with that and, you know, refine that science? Better geospatial tools, so downstream inundation, critical infrastructure at risk. I don't know how much this group works from the remote sensing or the infrastructure on the ground, but you know, when you have 1 million acres and you're trying to gather infrastructure information from a bunch of counties and cities that may not have GIS files, they might, like, how do we capture that? Bridge heights, I had a conversation with somebody that's working with a guy at Esri who's trying to do 3D mapping of bridges, because bridges are a huge deal in flooding. Like, what's the clearance under that bridge? I can see it on a satellite map, but I have no idea if that's going to be, you know, becoming a dam when a bunch of logs comes down, because I don't know what the clearance is. So working on that, mapping vulnerable populations, kind of standard stuff. And then a closer, from my point of view, closer relationship with the research community is what one of the reasons I'm here. Like, how do we do that? How do I know what research is underway? I don't know. How do you guys know what the operational needs are from somebody like me? One of the reasons I'm here today, but, you know, to continue this conversation, how does that conversation happen? Whoops. And then how do we connect that research to operational testing? Always a challenge. So that's
Very good.
we can save for the end if you want.
All right. Yeah, thank you, Katherine. So our next speaker is Ashley Teng, and let me bring up her slides here. Come on up. She is representing some work she's doing at the National Center for Disaster Preparedness. Yes. And looks good. Okay, so you can, yeah.
Oh, there we go. Hi, everyone. My name is Ashley Zinn. I'm currently a Master of Public Health student at Columbia University. And I was working with the National Center for Disaster Preparedness this past semester on building a community-based housing disaster recovery application. Do you have to use this?
No, that's that. There. Now you can use the down arrow.
Yeah. So a little bit about the National Center for Disaster Preparedness. It's NCDP for short. It is an academic research center through the Earth Institute at Columbia University. So they do a mix of work here. It's a mix of research, policy, and practice. There's over 100,000 individual learners through the online training programs. NCDP has conducted national surveys on preparedness attitudes and behaviors. It acts as an advisory role on commissions like the National Commission on Children in Disasters. It conducts longitudinal cohort studies on population disaster recovery with a child-focused community resilience and preparedness, model. So now I'll talk a bit about how NCDP has used data in disasters in the past. So on the left here, this is the 5 action steps to preparedness model that is designed to help individuals live with resilience before and after disasters. On the right, it is a screenshot of the preparedness wizard. And that is this tool to help families create emergency preparedness plans specific to where they live. But the preparedness wizard, it was created with state-level data sets, which NCDP recognized that was not granular enough to what people needed when planning for disasters. A few years ago, NCDP created a tool called the US Natural Hazards Index. It was originally intended to supplement the preparedness wizard I showed you on the last slide. However, the use of the US Natural Hazards Index has gone beyond the intended audience. NCDP found out that this tool was being used by those in the housing, insurance, and academic sectors. So it definitely had some far-reaching consequences that we did not expect when putting this as an open source tool to the public. Jonathan Surrey, he's the project director for communications and field operations at NCDP. He developed maps as such for Hurricane Harvey and Hurricane Florence for FEMA because citizen groups were asking about different resources for disaster preparedness and long-term recovery that they could use. As a result, NCDP was able to establish a lot of trust with FEMA during this 2017 hurricane season because it was the first time they were asking us for these specific tools to be developed. As NCDP delivered, it was great feedback from the community. And so this went into FEMA really turning to centers like NCDP to figure out more potential for technological capabilities, how to better engage citizens in the work that they were doing, and how to deploy tools as such into their trainings with community leaders. So applications like these, the just-in-time map applications, it's a situational awareness. So you can ask yourselves questions like, where and who are the vulnerable populations? Where are their toxic waste sites? How many schools are there and where are they? Where are the hospitals that are closest to these sites that are affected? For new trainings, NCDP knew that they would need new tools to act as a supplemental for trainings. Much of the attention around disasters is towards the response, but NCDP is really focused on the long-term recovery. And when we think about long-term recovery, it's the way risks are conveyed is different. And so there's a lot more different factors that you need to take into account when planning for long-term recovery. These are all the different contracts that FEMA currently holds with NCDP. And the bolded one is where this community-based housing recovery app falls under. FEMA trainings are really meant for the whole community, but this bolded grant contract, it's specifically for planners. When developing curriculum and designing trainings, NCDP follows this UN Sendai framework for disaster risk reduction model while keeping the UN Sustainable Development Goals in mind. So more specifically, it is building industry and infrastructure that is sustainable. and also paying more attention to the vulnerable populations that would otherwise be overlooked during disasters. NCDP conducted this needs assessment with community leaders and housing experts to kind of really figure out what they needed from the center to better prepare for disasters. These are the 5 main takeaways that are most relevant to this housing application. And I guess prior to this needs assessment, NCDP already had a general idea of what the community leaders needed, but actually conducting this situational analysis and knowledge analysis, we now had the evidence to move forward with that. So if we look at the main findings, you see a bit of a few trends. So there revolves around short-term rebuilding and also long-term planning. There's a lot of focus on information sharing and really getting to those populations that are harder to reach during disaster response. So then, yes, there's the inception of the tool. After this needs assessment, NCDP recognized the need for a community-based housing disaster recovery application, and this is when I joined the grant. So I'm going to go into more about how I guess the process of building this application. So Jonathan, he debuted this tool at the UN High-Level Experts on Water and Disasters meeting, as well as the pilot training event for the new training curriculum. So tools like these, they're intended to act as a decision support for community leaders. Based on past work in the needs assessment, we made assumptions regarding the hazard recovery process. For example, when we're talking about the pre-existing conditions that are exacerbated during a disaster, we're really alluding to socioeconomic variables there. Again, FEMA, they have this whole community audience. So this tool specifically is targeting planners and long-term recovery groups. Those are who are doing the case management during the recovery. But again, if the general public wanted to use this tool, they have access to it as well. And with this application, we really wanted to answer some key questions such as, where are the vulnerable populations in my community? Where can I place displaced persons in my region during a disaster? What is the proportion of homeowners with flood insurance? Is my community at high risk for flooding? Or how does my community compare to nearby communities in terms of social, economic, and housing factors? When selecting variables, I first conducted a literature search to find the best predictors of housing recovery. Overall, there was not a lot of literature out there, but there were some great resources. And so we see that with socioeconomic indicators and community indicators, education and income, those were great predictors. In terms of community indicators, aspects like religious centers, the number of schools, the number of community centers in a neighborhood, like those were very good indicators of recovery. And so we also incorporated different housing variables of interest, such as percent covered by home insurance, percent covered by flood insurance, and the housing stock type, which are either mobile homes or kind of big, large apartment buildings, things like that. When selecting data sources and the geography, ideally we wanted to use government agency data sets that were all open source. So you can see for socioeconomic variables, we use a mix of Census Bureau and CDC data, both at the census tract. And then with housing variables, we use HUD, Census Bureau, and also a private ProPublica data set. We decided to go with census tract geography because that best delimited, I guess, a community level geography. However, if we could not find census tract, then we would default to community level data. So this is the final map layers. We split them into 4 categories. There's the demographics, community, housing, and risk mitigation. So now I'll go through and show you some screenshots of the app of these layers. So this is the first one. This is flood hazard at the county level. It was extracted from a FEMA data set. You can see this is, since it's at county level, it's a bit larger divides. They're split up into low, medium, high. This is Houston over here, if any of you are familiar with the geography. The next layer, this is the Gini Index of Income Inequality. I think this is very interesting because you can see with the cities, so Houston's, that one, you can see like a cluster there. So in the city center, there's lots of inequality. As you move slightly out to the suburbs, there's low inequality. And then when you move out again, it starts to increase with inequality. And then to the left, there's also San Antonio, which follows a similar pattern. This is a poverty layer, which it's quantified by the number of households with income below the poverty level. And it, again, follows a very similar pattern to what you saw with the Gini index of income inequality on the last slide. Just darker red with more households with income below poverty level in the city center, and then moves out. This layer is low to moderate income population by census tract. So you can also see that there's a lot of missing data, which is, I guess, an issue that we run into when trying to get a whole nation-wide level data set on related or relevant variables at the census tract level. This is the CDC's Social Vulnerability Index, specifically the housing and transportation theme. So the darker the color, the higher the number, that means they're more vulnerable. And so the housing and transportation theme, this includes the number of multi-unit structures, the number of mobile homes, how crowded it is, if they do not have access to vehicles, and the number of group quarters. Oh, I don't know where this one went. Okay, well, this one was supposed to be showing the number of HUD public housing buildings. This is the number of homes covered by flood insurance through the National Flood Insurance Program. So anyone is eligible to purchase flood insurance from NFIP. However, you can see that this is the percentage covered, and the greatest percentage is 60% of people who purchase flood insurance, even though they're along the Gulf and they're very vulnerable. We think that there's such a low, I guess, purchase rate of flood insurance because it's not mandatory, so no one requires them to purchase it. And as a result, households don't want to spend this extra money as a precaution. Lastly, these are FHA insured mortgages. So an FHA insured loan, it's a government-backed mortgage insured by the Federal Housing Administration. FHA home loans, they normally require lower credit scores and down payments than many conventional loans. So again, it's interesting to see, I guess, the cluster around the city centers and then how it moves out and decreases. When the app goes live, it will be available on the NCDP website found here under the Map and Mapping Applications tab. And that is all.
So quite a different view of the need for data.
How's everyone doing? Still awake? A little food coma? All right, long week, a lot of great information packed into your brains, hopefully. So I'm gonna do the last presentation for this set. I'm Maximilian Dixon. I'm the Hazards and Outreach Program Supervisor of Washington State Emergency Management Division. So I oversee the natural hazards, geological hazards, preparedness, outreach, education for Washington State. So I wanna talk to you just, what are some data uses during disasters? But before I get into that, I'm going to tell you just a little about Washington State since you're here. All right, so Washington State has the second highest earthquake risk in the country behind California, second highest. We also have 5 active high risk volcanoes in Washington State, 2 of the top 5 in the country. So, and of course, with a high earthquake risk, we have a high tsunami risk as well. So, subduction zone. Everyone here heard of the big one? Cascadia subduction zone, 700 miles long. Yeah, from Vancouver Island down in Northern California. Yeah, so when this goes off, went off 1700, January 26th, I believe it was 9 a.m. When that's gonna go off, that's gonna be the biggest disaster, biggest catastrophic disaster we're gonna see in the United States. It's huge. Tohoku, 2011, Japan. Very similar type situation, subduction zone. They lost around 20,000 people. They lost over 28,000 ships that were destroyed, 26 large freighters, 319 ports. They had an economic loss of about $3.9 billion a day, and probably about 600 billion total. California, same event. Waves traveled all the way across the ocean. $100 million worth of damage, 24 harbors were damaged, and some of those still haven't recovered. Same event across the ocean. So these are huge, massive, massive disasters that we're talking about. So during a disaster, so when we're faced with this, something happens, let's say Cascadia happens, let's say we get a tsunami that's generated from Japan or Alaska, or maybe one of our volcanoes decide to go off, right? Something bad happens, now we're in crisis mode, we're in response mode. So, and Chris kind of summed this up, or it was a great intro at the beginning. Essentially, you got disaster occurs, first response arrives locally, because all disasters, they start locally, they end locally, right? So many different, if you're on the coast or you're in a major city or wherever you are at, let's say Cascadia subduction zone happens, you're gonna have 5 to 6 minutes of shaking. That's gonna seem like a very, very long time. Lots of damage, right? Then EOCs are gonna be activated wherever they can be, wherever we have electricity, the buildings are still usable, people can access them. Let's say if it's the middle of the night, which usually these earthquakes happen. Then, at a local level, mutual aid requests, county EOCs, Emergency Operations Center, State Emergency Operations Center, FEMA, Regional Response Coordination Centers, all of these coordination centers start coming along, right? Because we need to respond to this. So during this response phase, especially initially, a lot of times we're in the dark. What just happened? Okay, major earthquake. Yeah, but which fault? We don't know. How big was it? What was the impact? I mean, so we have all these questions. We have to start racing to gather information, right? To figure out what we need to do. So during this disaster, we are providing emergency alerts and warnings, right? So if a tsunami is coming, we're alerting the public as best we can. Obviously, if we had an earthquake, well, the earthquake was your warning until earthquake early warning comes live, which is starting to in California. So we go into the situational awareness because we need to know where are we going to be sending resources, who's going to be needing help, search and rescue, for looking at our transportation, doing preliminary damage assessments, figuring out for mass care needs, where do resources need to go, who needs it, how do we get it there, what our lifelines have been impacted. And we need to get public information out. So people need to know what's going on, where can they get resources, where can they get help, how long is it going to take. So one of the ways that we get prepared for catastrophic events like the Cascadia subduction zone earthquake and consequently tsunami, we do exercises. Cascadia Rising 2016, we had over 23,000 people participate in that exercise. It was a massive, massive exercise. We had Washington, Oregon, Idaho, we had partners from Canada, all levels of government, tribes, you name it. 23,000 plus people participated. That was huge. So during this exercise, or actually just before this exercise, NASA, some folks from NASA had reached out to me, JPL folks, said, hey, we've got tools. We have things, we have potential data and we could help you in a major disaster like so here's kind of this list of tools and data that we could provide. So I said, okay, great. So I have a little bit of GIS background, okay, but I started looking through this and I thought, all right, damage proxy maps. All right, so looking at using satellite imagery, we can look at the whole West Coast here. I know it's kind of hard to see in the back, but whole West Coast here of the United States. Okay, what just happened? So you had satellite imagery beforehand. The Earth has just it's been shaking for 5 to 6 minutes, and then now you got tsunamis coming in. What's changed, right? And this sort of snapshot where you can identify, well, how much displacement or deformation or how much change has happened here, where we can see what are the major spots for potential damage, for both from the tsunami or from the earthquake, and this gives us kind of a broad snapshot, situational awareness, right away to say, well, where potentially are the trouble spots? Where's the worst potential damage, right? It gives a great snapshot. Well, ran into some issues during the exercise that I didn't anticipate, because that's why you exercise, right? So I didn't have the technical capacity to, on the fly, figure out why these KMZ and KML files weren't working on our GIS maps and GIS software that we had. It's called WISE that we use internally. it wasn't working. I couldn't get it to work. And so, and I didn't have enough folks, or I didn't have enough knowledge myself. I didn't have enough folks internally to be able to problem solve that on the fly. So that was a huge issue. So consequently, I wasn't able to use any of this exercise, but also even if I had been able to use this and successfully load it onto our maps, I didn't know how to then have this map loaded on our screens in the Emergency Operations Center so that it could be usable by the folks that are needing to make decisions on resources and where to send people and sharing information. So that was also a difficulty. So some of these lessons learned, we realized, okay, we definitely have to identify critical data and information needs before the disaster. Okay, what do we need to know? And I label these as essential elements of information. And I have a list that I'll show you, just kind of a brief list on the next slide. But essentially, developing these essential elements of information, establishing procedures for collecting this data information, because you need to know, who do you get this data from? In what form? Is it email? Is it a website? Smoke signals? How are you getting this data and information? And then what's a backup? How long is it going to take? Is it going to take 5 minutes after the shaking? Is it going to take 10 minutes, an hour, a day? And what do you need? Do you need internet? Do you need a phone line? What do you need to get this? And what sort of software do you need to be able to use this data, right? So, and also, is this private sector data? Because one of the issues we had was huge, was critical infrastructure. What was damaged, putting it on a map. We had all kinds of issues with trying to get that information and then be able to put it on a map and figure out, well, who put that information in there? If you go back to, I think, the ORLs, Chris was identifying was, all right, how trusted is this information? How good is it? When was it put up there? Who put it up there? And then can we actually share that? Because everything that we have in the government here in Washington State is open for public information requests, right? So there's a lot of back and forth on how do we use this data, collect it, but then protect it so that private industries will want to share it with us, right? So this was something that we ran into as a big problem. And then tools. So again, GIS or WiseMap. How do we make sure that we can take these KML and KMZ files and actually use them and put them up on screens and then have it so that our decision makers, the governor and the director can actually make decisions off of this. It's usable, it's distillable, and we can manipulate it. Then procedures for how we use this data information on decision making. What are the roles and responsibilities? Who is responsible for pulling this? Who's responsible for testing it? Who's responsible for manipulating it? Who's responsible for, again, putting it up on the screen, or getting it to the policy room? And then standard operating procedures. So getting all of this tested and then implemented into our standard operating procedures, either as job aids or whatnot, so that people who are just coming in, who aren't familiar with this data or these processes, can look through this checklist or have this in the training and say, oh yeah, I know how to pull this up and I know how to provide this. These are all things that have to happen successfully in order for this data and information to be then used for decision making. And of course, training, testing, exercising constantly. So essential elements of information, some things that my team, we decided, well, we can help with. There's some things that we can do, and this is what we've been working on. So identifying these essential elements of information, such as what's the impact area, what's the building damage, power, communications, fuel, transportation, what's been disrupted, fatalities, injuries, where are the shelters located, what are our vulnerable populations, how about animals, how are they being handled? So a lot of these, we need to know these, right, to help save lives, sustain life, and help to get things going and not only in the response but in the recovery phase as well. So identifying what information we need, in the first hour, in the first day, in the first week, and then how do we get this information? Who do we get it from? When do we get it? How do we use it? And then how do we make decisions off of it? So then we decided, okay, we're identifying all of those. Now we need to map these. So we've created, now this one is a tsunami map for the Cascadia subduction zone. And so essentially you've got this whole tsunami warning area polygon here, and then inundation areas as well. And then I've also got these little dots, you can't see those, but those were our tsunami sirens are located. So there's a whole bunch of layers that are put into this that you can turn on and off. But essentially, we have one for wildfire, we have one for flooding, we have one for volcanoes, for tsunamis, for earthquakes. So, and we're still building, they're still testing these, but we have these ready to go with these layers, data layers already inserted. And then we can say, okay, what are we going to pull? Are we pulling, you know, weather forecast data that's going to be pulled into there? Great. Are we pulling, you know, who are we pulling from? WashDOT, you know, Washington State Department of Transportation, what bridges are down? So whatever is available, we've already pre-plugged into here, and we know what the other data sets we can plug in because we've started vetting that, and we have a process for that. And this simplifies, so we don't have a million different layers, confuse everyone, and you can't make decisions off of it. Pre-packaged, ready to go, ready to put up in the Emergency Operations Center. So these are some of the things that we're working on, very, very simple, but all the data behind that, the information behind that, answering these questions is hugely important to us, but it has to be ready to go. It has to be plug and play ready for us. And it has to be reliable so that we can get it consistently, it has to be from reliable sources. And it can't go through a route where we have to ask one person who asks another person who asks another person and then gets back to us and gets us the information. It has to be direct. So, you know, for instance, I have found out during Cascadia Rising, I, as a state agency, cannot directly ask for NASA data or information because, especially with satellites, because it has to go through FEMA or another federal agency. So there's some steps there that just are not going to work in a time-sensitive, you know, especially catastrophic disaster situation where you have to make decisions on the fly and things have to work because people are in a crisis mode and you're getting people in from all over who are not necessarily trained. So it has to be direct. But these are a lot of lessons learned. These are things that we're working on. So I just want to give you a snapshot. And here are some resources, just Washington State Emergency Management Division, some resource websites, Department of Natural Resources. We work very heavily with them for their geological survey, also for wildfire, and then NOAA and USGS. So thank you.
Thank you, Maximilian. That was excellent overview. So we have quite a scope of issues that we've been looking at, and a lot of the topics are quite familiar. What I'd like to do is we have also invited our panelists, and so let me pull up so you can know who they are. Back in last month, we had a webinar to talk about what federal data is available from JPL, NASA, from USGS, NOAA, and FEMA. And so I think at this point, all of our, well, let me just ask Dave, all of our representatives available online? What we might be able to do is just kind of go round robin for a couple of minutes with each person for some ideas about the big issues that we've been looking at, and that is how do you discover this trusted data and how do you access it? And as Maximilian was just describing, that you know, he needs, if it's going to be a request for data, a direct and immediate response. Would we be able to do that? Let's see. It could be that others cannot.
Hi, Karen, did you want us to respond to that right now? This is Maggie from JPL.
Yes, that would be,
okay,
that would be just a couple of minutes each.
Okay, sure. I'm actually going to defer to Jeremy Kirkendall, who is the one of the GIS leads for the NASA GeoPortal. And I'll let him sort of talk about our internal process for posting information and pulling information from our portal, and we can field any questions regarding that after the round robin.
So when we post our products, we've recently started posting them through a collaboration with NASA's ArcGIS Online account. and we just started to enable the open data feature for some of the layers, which means if you go to an open data search engine, like Google has a search engine just for open data sets, and if you were to search for NASA in there, you would start to see our layers that we've shared through that process through there. So a lot of our older stuff isn't updated to those standards yet, but it's something that we're just in the process of starting. And if a lot of the other agencies were enabling open data on their data sets as well, then you wouldn't necessarily have to go to individual portals to find these different agencies' data sets. They would all be found through one place. And if all you're doing is sharing it to ArcGIS Online but not enabling open data, that's still getting you halfway there because you can use the ArcGIS Online search engine.
And so as long as there's kind of a de facto standard based on ArcGIS, that solves a good portion of the problem then?
Yes, and we are also enabling WMS endpoints on our services. So for the people that are using open source software, they can read our WMS endpoint.
Very good. Yeah, thank you. Marie Peffler, do you have some thoughts for us?
Yeah, hi, this is Marie Peffler from the U.S. Geological Survey. I'm the emergency management coordinator for the survey, and I've worked in kind of all of our different varieties of data that we put out. The USGS is the largest primary observations agency, and our job, I mean, a lot of people talked about how they bring data together, and a lot of that data is kind of our data that we kind of observe. We actually are the ones who manage and maintain the stream gauges and the rain gauges and the seismometers and the gas sensors that all sit on those volcanoes and rivers and beaches that everyone's sort of talking about. And in order to kind of manage that massive amount of primary information, we have a whole host of products. And as I said to Dave earlier, I mean, I have hours-long workshops on how to access and use our data streams, and I'm happy to kind of present that at a later date. But the earlier presenter said, you know, how do we get a hold of your data? And the answer is, for the USGS stuff, it's as varied as our data to begin with. We have, we host web services, web pages that are for direct use, and then direct alerts for the data dissemination. Many people are probably in this area for sure are subscribed to our ENS notifications, or the earthquake notification system, where you can get a message when, you know, things start acting awry, as it were. So we do direct alerts, and then all of our data streams are open data available on data.gov, and we participate as much as we can in the Disasters Geo platform, which is kind of a central location that one can go to kind of access all of these individual components. And then for some processes and issues, we do go one step further and then take that kind of basic information and turn it into sort of risk information. What are the consequences of these actions? How often do we expect these types of events to happen? Sort of probabilistic estimates of different magnitudes, earthquakes, frequency of flooding, and then flood extents as well. We kind of map and monitor all of those different pieces. So I feel like I can't possibly sum it all up in like 3 minutes or less. So I'm going to stop there and let the conversation continue back around.
Thank you, Marie, and we definitely would like to take you up on the offer to get more detail about USGS data products. Carrie Sheets, can you share some thoughts from a National Weather Service perspective?
Sure. So much like both of the other agencies have shared, we also make most of our services available as REST services. We are bringing on some data later on this year through using the GeoServer open source software for some of our like radar information and some of the more dynamic raster data sets. So those may not have the full REST endpoints, but they will be completely OGC compliant as WMS services to start with. And then will come on board probably as the standard emerges for web coverage service. We're actively working with OGC on web coverage services for Met Ocean data. NOAA is very active in our GIS online community, and we have a NOAA Geo platform through that, and we also try to populate the disasters Geo platform as we can, primarily by pushing from the NOAA Geo platform. We have weather.gov/GIS for GIS information, and then other information that probably most everyone that has a cell phone is familiar with is our dissemination office also handles like the emergency alert system. So not so much data that you can add to a system that you have, but when your phone starts buzzing, that's because we're using CAP 1.2 protocols to push that to the cell providers, and then they push it to you. Kind of along those lines, we, yeah, I guess that's probably the best way to go with that.
Very good. Yeah, and it does seem that Emergency Operations Center, I think, in general, are quite familiar with some of the major NOAA products. And I know with our work, the ESIP's work with the All Hazards Consortium, quite a bit of effort to bring in some of those new products. So I think there's still more opportunities there. Chris Vaughn, could you tell us a little bit more then about FEMA, just in your ideas?
Thanks. Yeah, first of all, it's a pleasure to be with you today. A number of comments. I guess we, FEMA, support, like many of the other federal agencies, we're under a directive to share as much data as we possibly can through open data initiatives. So FEMA actually has FEMA.gov/open data, where we're putting a lot of our information out, especially as it relates to disaster funds and disaster-related, post-disaster-related incidents. From a geospatial perspective, FEMA is pushing out a lot of information as well, once again through things like OpenFEMA. But we're also collaborating with others on a website called disasters.geoplatform.gov. We spoke about that at the last session. So a lot of the information that's coming out, especially from the science communities, right, the NOAAs, the NASAs, the USGS of the world, right, that's going out in some pretty authoritative fashions already. I just wanted to comment on the one gentleman's comment, and obviously I caught on to it because it sounded like FEMA was a middleman in getting access to data. A lot of the folks that are in this are really trying to work through the workflows. So in particular, and I don't want to speak for the ARIA program, but they're trying to set up, what they're really trying to do is set this thing up so that it's automated. So actually get the humans completely out of the loop. So if an earthquake occurs and it hits a certain threshold, X number of miles down, X number of MMIs on the scale, it's automatically going to be searching for any and all available data that's out there, inclusive of Sentinel 1, 1A, and 1B. And they will automatically kick off that process. So it's not like you've got to go through a number of checks and balances to get access to the data. They're trying to set this up so it's fully automatic. We're all looking for those automated workflows because that's what kills us all in time. So I think the more satellites that get thrown up in the air and the more that we work through the workflows and automate the processes, the better off that we're all going to be. The last pitch for that is on that disasters.geoplatform.gov website. We're also trying to give out our methodologies and workflows. We're trying to push those out there on that website so you can be aware of where it is we're coming from when it comes to things like floods, earthquakes, and tornadoes. Thank you.
And Chris, just a quick question on that. When you described a situation if an earthquake hits, that there's a certain threshold of the area that you would automatically, or the desire would be to have an automated procedure to collect data for that region that's within the threshold. Then it must also be a procedure that is generated before the fact so that those products are known and available, so that that they're accessible through the FEMA tools. Is that right?
You had me all the way up until you said FEMA tools. So yes, from a FEMA perspective, you know, we're trying to develop our own tools, but the product that I just referenced was NASA, and yeah, they are setting things up using automated programs. The ARIA program in particular is what we were talking about, and it's something to say. It's amazing, this concept of open data. They're doing what they can. ARIA is doing what they can because of open data, right? The Sentinel program, Sentinel 1 through 6 or more, I guess, is it comes out of the European Union, and they're donating it. They're making all that data completely free, just like the USGS in particular. The US is making Landsat data open data. NASA is in just a few years going to launch a new SAR satellite called NISAR. That's going to be free. So more and more of the government civil satellites are being launched and open data. And as a result, all of these great applications that automate those workflows are starting to come online. It's just a great time to be in the community.
Very good. Well, I'd like to open it up for anybody on our panel, anyone who is remote. I am monitoring a chat window. Questions to talk about, how we find and access these federal data.
Hey, Karen, can you hear me? This is Dave.
Yes.
Hi, Karen. It's funny. I was trying to use my computer to talk before, and no one was hearing me, so I got to figure that one out. I have a question for Maximilian because he did, and Chris may have been referring to what Maximilian said too, and that is that the state of Washington can't ask for data directly from NASA. Is that something that's I had never heard of that before. I was just wondering, does the governor have to declare a state of emergency and then they can get different authorities to ask for information, or does that request have to officially go into FEMA?
This is Maximilian. Good question. So essentially, and I can't remember exactly where this is stated in law or policy, but essentially what we ran into was based on satellite products that we wanted to request at the state level, we could not request that directly from NASA. It had to go through FEMA. And this was just through some requirements, and I can't name exactly where they're at, but we did some extensive research and found out that was the case.
So go ahead. I think Maggie, you might.
Maggie, Maximilian, is that something that's state of Washington specific? Because there shouldn't be any requirement as far as NASA is concerned for you to request data from us.
That's not a Washington state specific.
Okay, well, I'd just like to clarify that if there is a request for NASA data, that you can come directly to NASA for that.
Well, it's good to know. All right. Well, yeah, because anyway, I don't want to sidetrack this conversation, but I want to fact check that through some documented legal. Yeah, I want to go through that route. I need some documentation.
Why don't you go ahead and follow up with me? You should have my contact information from Cascadia Rising. Is that you? Do you still have that?
I do, and I will follow up with you, Maggie. I appreciate that.
Okay, sounds great.
And I actually have a question for Christopher. So for this automated pulling of data, let's say when an earthquake happens, who are you saying specifically that the ARIA through NASA is doing this, leading this, and that's going to be made available, or what partners? Or I was wondering, I want some clarity on how do I find out more information on how this is being developed, who's going to be able to access it, and just staying up on it.
Chris, would you like NASA to field that as well?
Yeah, it's your program, please.
Sure. So Maximilian, again, the ARIA project is centered at JPL, and their information is freely available, and their automated system is the information is freely available. So if you want to follow up with me on that, I can give you that information as well.
Very good. We have a comment or question back there.
So I had a question with all of the agencies supplying data, and some of the data somewhat overlaps. If there's differences in what the data is actually showing, what would the community do as far as suggesting which is the authoritative source for, say, an earthquake, USGS, but then again, it might be a tsunami. So what should the last authoritative source be?
Yeah, so this is Marie from the USGS. I'll tackle part of that, which is you should always go the furthest upstream that you can, and it varies based on the event. So you hit the nail on the head. Earthquakes, you're going to come to USGS, but tsunamis are put out by NOAA. So it is sort of a maze, and there is no guidebook per se that can help you through that. We try, though. Chris and I can wax poetically for hours about how much we try to help people navigate that maze. And Disaster Geo Platform is one place where we're attempting to do that, but it is really challenging. There is no golden ticket.
And I'd just like to say on behalf of NASA that we're not an operational agency, so we support USGS, NOAA, and FEMA with our data products. And so we make available our scientific data products as a value-added data product, and Jeremy can expand on that.
Our products are considered research products and experimental. So while a number of them have been around for quite a while, they are still being refined. They're not operational, so the standards are a little different. And we may throw out 3 different flood products based on different algorithms, even from the same data source. But our view is if all 3 of those products say there's flooding in one spot, then we have a higher confidence that there is flooding there. So it's better to have more data.
Yeah, and this is Carrie from NOAA. I would say, and I hate to say this because I hate it when people say it to me, but you really have to read the metadata because just like NASA just shared, even within NOAA, we have research organizations and we have official forecasting groups. And the official forecast, like from tsunami, the Tsunami Center in the case of the tsunami would be where you would get your direct data, but even like tsunami is a great example of one of those sticky subjects. So the earthquake that probably initiated it would have come from USGS. The actual where's the tsunami going, and those warnings will come from NOAA. And then, but then if it had something like the Japan situation where you have air quality issues, then EPA comes into the mix as well. So it's just not always clean cut as to who has the authority in the area. It usually has to do with the laws that fund us as to who actually has the authority over the data.
So this is Maximilian. From a public perspective and from emergency management perspective, it's really about the source that you know and trust. And so that's not necessarily, say, like as was described here, USGS for earthquake or whatnot. I mean, there's some that are really well known, but essentially you take what you can get and which one's the most trustworthy for relationships, or the data is complete, or you've used them in the past, and there's a number of different ways of doing that. But essentially, it's whatever you have at hand and the most trustworthy source during a disaster. Now, if you have sort of blue sky pre-disaster, then yes, then you've got those roles and responsibilities and authorities for different federal agencies and state agencies, local agencies. But it gets tricky.
I was going to say that we heard about the ORLs, the operational readiness levels, and I would think that this kind of nuance about the authoritativeness of a data product on a use case that's oriented towards a tsunami, that would be a good exercise to go through to kind of work those details out And then when you evaluate the data and you're going to assign an ORL to it, you take into consideration those levels so that once it gets to the point of being used, there's no one's going to be going in and looking at metadata at that point. They're going to quickly be able to see an ORL designation that's going to tell them, just which data is their trustworthy one.
And this is Chris, and you're absolutely right. And the ORL process forces that conversation. It also forces the conversation, and Maximilian said it. Okay, this is my authoritative ORL1 best case scenario, but what if I can't get to it in the disaster? What are my fallback positions for other data and other ways of connecting to that data? Because he said it perfectly. It's got to be in place before the bad thing happens. And what's happening too often is EM agencies are grabbing data in the moment, and they don't know all these nuances that have just been discussed in this session, and so they don't know what they're looking at. They don't know if they've got it from the right people. They don't know if it's going to be reliable, and that's why all this pre-planning that the ORL process forces is so important.
Yeah, thank you, Chris. So do we have any other questions? Yes.
So I've heard a lot of discussion about web services that are being built, and that's fantastic, kind of in the moment as the disaster is happening. I think that's by far the most efficient way to get data out if you're looking for a single point. But is there any discussion about how to balance that with bulk data access? And the reason I ask is that kind of, before the event, the people that may want to train machine learning algorithms to detect these kind of things need that bulk data access to have that as a training data set so they can actually teach the algorithm. And is there any discussion about how that's being done? Is that kind of outside the scope of this session? Any of combination of those two?
Yeah, I have some ideas along that line, merely because our ESIP meeting this week has really been looking into machine language, but I'd like to open it up to, I meant machine learning, open it up to the panelists and see in terms of identifying, you're basically asking about identifying these large data repositories and pulling out the appropriate data that would be useful for this application, and then using that to as a training data set for future machine learning.
Yeah. This is Crystal, and I'll take the first stab at that and defer to the rest of the group if I may. So we're in full support, right? I just came back with many of the folks in the room actually. Was out at the Edge of Users Conference last week, and that was the talk of the conference, was GeoAI. There was a number of folks, especially in the insurance industry, that's using high-resolution aerial imagery to automatically extract damage assessments from imagery. That's clearly the trend. We're getting closer to that realization. We've talked for the last 20, 30 minutes about ARIA, which is ostensibly extracting information automatically from co-registered SAR images, right? So that's where the industry is headed. There's tons of imagery available. The only way to get through that is to use, whatever fancy word you want to use. CNN, deep learning, machine vision, whatever. I really think we're probably 6 months to about 2 years for really seeing a major turn on all of this. From our perspective, at least from the FEMA GIS program, I would offer that we have, from a labeling training data set, if you go to disasters.geoplatform.gov and look up historical damage assessments, we have put out 10 years worth of top-line damage assessments that we've done from a geospatial perspective. There's got to be well over 1.5 million labeled data points on individual structures spanning the last decade. I think that's by far one of the best to put more and more data out like that so that the community, vendors, academia, the science community can go back in time, hindcast events, and help us prepare for the next estimate. So that's where we'll support. I'll turn it back over to the panel.
Thank you. That's an excellent suggestion. Any other responses or comments?
So as far as NASA goes, we have a lot of PIs that do machine learning, and so those will feed into our portal. But I don't think that the portal itself will be machine learning enabled. I think that it will take the outputs of the investigators' algorithms and post those results to the portal. But the portal is mostly a GIS enabled map service.
Yeah, and I guess my point there is that the is helpful and is supportive of users as the map services are. Just want to make sure they're not done entirely at the expense or at the cost of bulk data access as well, to support both of those use cases and both of those needs.
Very good.
So, sorry, this is Marie from USGS. I just have one quick comment, which is the USGS is using a lot of machine learning in order to do some primary QA/QC and help enforce our QA/QC process and ensure that we're visiting the right stations at the right time, since that's our primary goal. And we do have a lot of primary data that can be used to calibrate these sorts of models. When you've got enough data to go around, you can kind of split it up and use your calibration confirmation issues. And if people are interested in bulk data and they cannot find the web services, or commonly the much older data sets are archived and available kind of in a different location than the primary real-time data sets, just reach out to me and I can get you in touch with the right group in order to get access to that historical information for calibration and AI.
Excellent.
Hey, Karen.
Yes.
This is Dave Jones. I see on the clock we have, oh darn, it just went to 4:15. I was going to say we have at least 15 seconds. I was just wondering on the issue of timeliness for access to these data, if the panelists could just go through just quickly and say, you know, is a lot of your data available in real time to, you know, a couple of hours? Is it available from, you know, 12 hours to 24 hours with the data sets that you work with? Because that's an important piece that goes into the definition of the operational readiness level, but also just to keep in mind that, you know, how quickly can data turn around to feed into the decision-making process?
So
go ahead.
We all probably jumped at once.
Yeah, so with NASA products, it all depends on the satellite overpass, and because we're not operational, it's a best effort. So if the satellite data is captured on a weekend, the scientists might not be available, especially if it's not a really, really major event. So the delay for NASA products really depends. We have some near real-time products that do get updated within hours of the data being processed, and other ones it may take a day or two.
Yeah, this is Chris. I'll echo that. It just depends, right? So right now, a lot of, from a FEMA perspective, the battle rhythm for a hurricane is every 6 hours. Why? Because that's when the hurricane updates come out, right? So that's you know, we're kind of beholden to when the forecasts come out is every 6 hours. We have a hurricane journal that's automatically scripted. As soon as a new update comes out, we automatically rerun our models, and that's automated. So we're trying to build to what the data streams are coming out, right? There's a lot of hope in things like the National Water Model coming out of the National Water Center. That's going to be a lot faster than every 6 hours. So I would just say it just really depends, especially on the type of use and application that you're trying to go after. But yeah, to the fullest extent possible, I think we're all trying to automate.
Yeah, this is Carrie from the National Weather Service, and ours is as near real time as we can get it. And when I say that, I mean to whenever, kind of like what Chris just said, when the products come out. So once Hurricane Center issues a new like track and cone advisory, then we're grabbing their files, converting them in an automated way and getting them out there. So there may be a couple of minutes in that case, but those are products that are issued usually every 6 hours. When landfall is imminent, it goes down to every 3 occasionally, or I should say for some products. But for things like radar, we have a constant feed going. So it's updating about every, I think we've got that one set to 45 seconds. So yeah, we scrape the data source as frequently as that data should be updating.
Very good.
Okay, wait. So this is Marie at USGS. For us, it depends on the data source and the data sensor. So our seismometers, gas sensors, and geomagnetic network are milliseconds to transfer that information and potentially start issuing alerts in the earthquake early warning network. But that's the high end of the range. The stream gauges transmit anywhere from 5 minutes to 15 minutes to 1 hour, depending on the system. And it depends on kind of the different telemetry options for each instrument. So, but in general, we're trying to get those stream gauge transmissions down to every hour. Commonly, when they show a high rate of change, they'll start transmitting more often. And then that's sort of our 2 primary networks are going to be the seismographs and volcanic networks and the stream gauges. So that is going to be your primary data sets, and those are all available via live web services. Typically, the delay for QA/QCing the stream gauges is going to be about 2 minutes from transmission to web service, public web service, I should say. And then with the seismometers and the alerts and the earthquake early warning, like I said, those sensors do their own alerting. So it's about as fast as you can get. Thank you.
That's great. Thank you, guys. Thank you.
Yeah. So
what I think is an important part of this conversation, Karen, though, is that that information that was just shared.
Yes.
I can count on one hand the number of operations people who are using this data that know any of that. So through the ORLs, part of it, and the accompanying standard operating procedures, when you're a decision maker, you should know how rapidly that information is getting updated. And that also ties into how often their GIS platform is refreshing the service. So that's a key piece of information, and very few of them are aware of the variance in most of them know the hurricane update cycle, but beyond that, they don't know. This is a challenge we're taking on with the All Hazards Consortium, is teaching the decision makers to learn and train to these different update intervals and all these nuances that go into using these to make life and death decisions. So if everybody on the call would kind of also take up that challenge of, you need to know these things when you're in an operations center deciding on what your course of action you're going to take. It could be in an acute situation like a severe weather event. You need to know how fast that radar is updating, or in a more macro situation like an earthquake. It's a really big problem.
And I suspect that, I mean, what I could envision is a table listing the data and then identifying some of those key parameters. And indeed, that's what the operational readiness level kind of goes through, that kind of criteria with the group who would actually be using it for decision making. So that's something to think about. If there's ways of accessing that information, I'm sure it's available in some form, but making sure that the people who need to know it know how to get a hold of that.
Whoops, I'm sorry, Karen. Yes. I know you said we're out of time. We're out of time, but I just wanted to say it's going to be really important for us to know as well from various agencies, like on the authoritative data part, which ones are the ones to turn to for things like flood modeling. I mean, if NASA does 3 versions of flood models and puts that out there, but NOAA and the National Water Center have the official flood model, we want to make sure that we use ORLs to point people towards the trusted authoritative source. And then if there are others out there that they can consider, maybe that's a different ORL number. But we want to make sure that we're not accessing a bunch of different types of flood models from different agencies that could cause confusion with not only emergency managers, but also the public.
Very good point. And I think that gives us some food for thought within our ESIP disasters cluster here to move forward. Well, we're really getting close out of time, but I did want to ask Don Sullivan to come forward. There's been some very recent results with planning an OGC test bed focused on disasters, and it would be useful just to have a few comments. So Don, if you could share.
Yeah, I prepared a presentation I'm not going to give so you can all get out of here. Again, my name is Don Sullivan. I work for NASA at the Ames Research Center in the Silicon Valley of California. My primary hat is I'm a system designer for the Airborne Science Program, but in this particular case, I'm wearing the hat of the one of the chairs of the Emergency and Disaster Management Group inside the Open Geospatial Consortium, and we've been working with the innovation program there to assemble a pilot. A set of exercises to address precisely Maximilian's problem of, well, the damn thing doesn't work. Why not? Why doesn't it interoperate? And so there we have funded 9 different entities, universities, corporations that I'm not allowed right now. This is brand new. I'm not allowed to list the agencies, but I did put a presentation on the website. You can get it, and it lists the different aspects of the pilot, what things are being addressed, and the playbooks and cookbooks that are going to be the results of them. So I'll let you all get to lunch. Thanks.
Thank you, Don. Yeah, I brought up the front page here. So all of our charts will be available at the ESIP archive. This session has been recorded. I really want to thank all of our presenters, and both remote and locally here. And thank you for staying over time with us and helping us really explore a pretty fascinating area, in my humble opinion. So thank you very much.
Thank you, everybody, and thanks to all the panelists. Appreciate your time.
Thank you.